Okay. Hello everyone. We'll start the paper discussion for physics, part test number 8. Please take out your question papers and keep them with you. If you can't see anything on the screen, if you can't see the question on the screen, keep your question paper with you. Okay, so the first question says, two rods of the same length have their area in the ratio 3 is to 2 and thermal conductivity is in the ratio 4 is to 3. The ratio of their thermal resistances will be. What is thermal resistance? RTH is equal to L over KA. L is length, K is thermal conductivity, and A is area. So A1 by A2 is given as 3 is to 2, and K1 by K2 is given to as 4 by 3. Okay. What is R1 by R1? R1 by R1 is going to be A2 into K2 divided by A1. Okay. So this is L divided by KA. Okay. Same length. That's why L is not there in this equation. So what is 18 by A1? 2 by 2. What is K2 by K1? 2 by 2. This is 1 by 2. Okay. So correct answer is option number C. Okay. That's it. 27. It says that length of straight string is shortened by 40%. So let's say initially the length of the string was L. If it is shortened by 40%, that means L minus 0.4 into L. So length is becoming 0.6 L. The tension is increased by 44%. Tension is becoming, if it is increased by 1.44% means it is becoming 1.44 into T. Then the ratio of final and initial fundamental frequencies is, what is fundamental frequency? Can get fundamental frequency as V divided by 2. Okay, where V is the wave speed. How do I write V? I can write V as square root of V by V, and I will write this as 1 log 12. Okay, this is fundamental frequency. So the ratio of final and initial fundamental frequency. Let's say this is initial fundamental frequency with length L and tension T. What is the final fundamental frequency? The final fundamental frequency is going to be 1 by 2. What is the final length? The final length becomes 0.6 L. 0.6 L into square root of T by B. What is the new tension? New tension is 1.44 into divided by B. The linear mass density is the same. So just divide it slowly. Final by initial. So you have to do F2 by F1, which is nothing but. So 1 by 12 is cancelled. You are getting 1 by 0.6 into what is this? Square root of 1 by 4. This is nothing but 2. Okay. So correct answer is 2 is to 1. Final by initial. It is 1. Next one. A pipe closed at one end. A pipe closed at one end produces fundamental note of 412 hertz. Okay. It is cut in two pieces of equal length. The fundamental frequency is produced by the two pipes are. So if you cut this pipe into two lengths, two equal lengths, okay, what will happen? There is going to be one open organ pipe and another one is going to be the closed organ pipe. Let's say this length is L, this length is L by 2. This length is also L by 2. And if this is 412, can I write F is equal to B divided by, what is the fundamental frequency formula for the closed organ? For closed organ pipe, it is B by 4. Now this is an open organ, open organ pipe. What is the fundamental frequency for open organ pipe? B divided by 2 into length. What is the length of this open organ pipe? L by 2. Hence I write down L by 2, which is nothing but B by L. Okay. This is the closed organ, closed organ pipe. Again, the fundamental frequency for this is going to be B by 4L. Okay. What is the fundamental frequency of this. What is the length of this? L by the video identifier. Same frequency. Okay. So what is this value? So 412 is equal to V by 4L, right? So if you substitute this value over here, you are going to get this will be equal to 4 into 412. And again, here I can write this as 2 into V divided by 4. Clear? I can write it like this. The fundamental frequency of the closed organism. So it's nothing but 2 into 412. Right? I got the frequencies. So this is for open organism and this is for the closed organism. So which option is matching? I believe um, this one. D. Okay. Right? Next, we'll see question number 29. Okay. So in 29, it is saying stationary wave equation is given. You need to find the separation between the two consecutive nodes. What is the separation between two consecutive nodes? The separation between two consecutive nodes is basically lambda by 2. How do I know this? So stationary wave looks something like this. Let's say this end is fixed, this end is also fixed, and these are the other extremes. You can clearly see the distance between two consecutive nodes basically lambda by 2. Okay, that's why I put separation between the two consecutive nodes is lambda by 2. Compare this with y is equal to 2a cos kx sine of omega. This is a typical standing wave equation. Compare this. You will get k is equal to 5 by 20. Right? What is 5 by 20? I can say k is also equal to 5 by lambda. From here, I will get lambda will be equal to 40, 40 centimeters. Okay. And the separation from this equation, I get lambda as 40 centimeters. And the separation is going to be substitute this value 40 centimeters over here. So 40 by 2, nothing by 20 centimeters. Okay. So the answer is 20 centimeters. Okay. Next one. So 4 moles are of the perfect gas are heated to increase the temperature by 2 degrees Celsius. So delta T is 2. Absorb the heat of 40 calories. So Q is equal to 40 calories at constant volume. Okay, constant volume. So I just wrote whatever is written in the question. Then if the same gas is heated at constant pressure, the amount of heat supplied will be R is given as 2 calories per mole per Kelvin. Okay. So this is a typical thermodynamics question where you like Q for constant volume. Obviously for constant volume. Can I write Q is equal to NCV delta T, right? 4 moles Cv is unknown, delta T is 2, and Q is 40, right? From here, I will take Cv will be equal to 40 divided by 8, which is 5 calorie. I wrote calorie here because 40 is calorie. 40 calories is the heat. So unit of the heat is given as calories. That's why the unit of Cv will also be calorie per mole per Kelvin. Okay. Delta T for delta T, Kelvin and degree Celsius is same. So I got Cv value. Can I write Cv value? Cv is nothing but Cv plus R, which I got it as 5 plus 2, which is nothing but 7 calorie per gram, not per gram, so calorie per mole. So how much heat is required? So I write down at constant pressure. The question is asked how much heat is required to increase the temperature by same amount at constant pressure. Simply write this and simply delta. Right? At constant pressure, K is equal to 1 centimeter. 4 into Cp is 7 into 2. This is 56 calories. Okay. Clear? Simple. Question. Q equal to MCV delta T for constant volume. Q equal to MCV delta T for constant pressure. Next is when 20 joule of work is done on the gas. Gas. This is important. Work is done on the gas. So if the work is done on the gas in physics, you have to remember work done by the gas is positive, work done on the gas is negative. Hence, Q is equal to minus 20 joules. Okay, and 40 joule of the heat was released. Again, sign convention is heat absorbed is positive, heat release is negative. Hence, sorry, this is I close this. This is not on the gas. So I restart this question. So again, so 20 joule of work is done on the gas. So work is minus 20. Okay. Heat release. If heat is released, Q is equal to minus of 40 joules. Understood? So 20 joule of work is done on the gas. That's why negative. Heat is released. Again, that's why negative in physics. Work done on the gas is negative. Work done by the gas is positive. Also, heat absorbed is positive. Heat released is negative. Then, in the initial internal energy is 70 joules. Y is 7. You have to find the Q. So, first law, Q is equal to delta U plus W. Q is minus 14. Delta U is UF minus 1 plus W is minus 20. Okay. Minus 14 is equal to UF minus 70 minus 20. So, UF minus then it will as so 110 17. Okay, so initial internal energy is 70 and work done is minus 20. He goes released. So here I will get it as uh, 90 minus 40, which is nothing but 56. So this is the final internal energy. Clear? Next one. Two rods of same length having conductivities and areas are connected in parallel to each other. The effective conductivity of the combination. This is similar question that was asked in previous part test, but here it is directly shown that they are connected parallel to each other. So this is one rod, this is another rod. Here let's say temperature is T1, here let's say temperature is T2. Okay, I can replace this with this particular system. Okay, temperature T1, temperature T2, resistance R1, resistance R2. I can simply write R2 is equal to N divided by Ka. So let's say this has thermal conductivity 120. So this is 120. And what is the area? 0.4. N divided by K into A. Thermal conductivity is 120 and area is 0.4. The first one. R2, I can write it as again same length divided by what is the thermal conductivity? 80 and area is 0.6. Okay. So I got this as R2 is equal to L over 48 and R2 is L over again 40. Right? So from here, R equivalent is going to be these two are in parallel connection. So hence I will write 1 by R equivalent is equal to 1 by R1 plus 1 by R. Okay. So I will get R equivalent as L divided by 96. You can do the calculation. Now I have to calculate the effective conductivity of the combination, not the effective thermal resistance. So I will say the effective system. So effective thermal conductivity means what will be the thermal conductivity of the material which is having the exact same shape and size that of these two materials combined. So this is temperature T1, this is temperature T2, this is thermal resistance RTH. Okay, or I can say RTH. So I can write R equivalent as L over K equivalent into A. Now, what about the area of cross section? What is the area of cross section of these two combined? The area of cross section of these two combined is 0.4 plus 0.6. This is L by L1. K equivalent into 0.4 plus 0.6, which is nothing but L by K equivalent. Simply equate these two. Equate R equivalent and here also I found some R equivalent value. Equate these two values, you get K equivalent as 96 watt per meter per kg. Clear? So you can do this for any type of question. All you have to do is find out the thermal resistance equivalent, then write down one single resistance. Write down L divided by K equivalent into area. This area is basically the combined area of these two. Length is common. Hence, compare the R equivalent which you found using these two connections and the single resistance. Compare these two, you'll get the value of K equivalent. Okay, next one. A long elastic is held vertically in water, but uniform is done. This is the resonance question. Now they are saying that okay, the strong resonances are observed at successive lengths 0.5 meter and 0.84 above the surface of the water. Okay, so L1 I will say is 0.5 meters, L2 is 0.84 meters. So if strong resonance is being found at these two lengths, and what are these lengths? These are the length above the surface of the water. So let's say one time the surface of the water was over here, and I will say this length is 0.5 meters. The other time the surface of the water was over here, and this particular length is 0.84 meters. They are saying that at this level of water and at this level of water, you are observing a resonance. So, can I say resonance will occur only if there is a standing wave form? When will the standing wave form over here? Something like this might be possible. Okay. So, when the water level is at this point, there is a standing wave formation. Hence, you are able to hear the resonance. When the water level is at this point, there is a standing wave formation. So, these are the successive lengths. So, can I say this gap between this water level and this water level, basically lambda by 2, it looks from the diagram, you can interpret that this distance is lambda by 2. Hence, I will say lambda by 2 is equal to 0.84 minus 0.5, which is nothing but 0.34 into 2. Lambda is equal to 0.34 into 2. What do you need to find? You need to find the tuning frequency of the tuning fork. Okay. Velocity of the sound is given. You have this relation. V is equal to lambda f. Velocity of the sound is 340. Lambda is 0.34 into 2. Frequency is what you need to find. Okay. From here, I get frequency as 100. Okay. Okay. There is a formula to calculate this as well, but if you don't remember the formula, this method is aggressive. Okay. This is a black body radiation problem where you have to find the graph between intensity and wavelength is given below. One relation you already know that this lambda m is the maximum, is the wavelength corresponding to the maximum radiation into T. Temperature is constant and the value of this constant is 0.0029. Okay. So can I say the more the temperature, the less the wavelength corresponding to the maximum radiation? Okay. You can clearly see here. This is the wavelength corresponding to the maximum radiation, and this is the wavelength corresponding to the maximum radiation. So this wavelength is less than the wavelength for the second case. That's why this temperature T1 is greater than T2. Sorry. So if the wavelength is less, the temperature is more. That's why T2 is greater than T1. If lambda 1 is greater than, you can see lambda and the temperature, they have inverse relation. This is a Green's displacement law. Based on that, this option is there. In option D, you should get the wavelength corresponding to the maximum radiation for T2 is more. Hence, T2 is less. That's why it is wrong. Here, they are exactly the same. Basically, this is wrong. In option D, they are crossing each other. That's why it is wrong. Okay. You have to find out the work done in AB, BC, and CA respectively. So I will draw the diagram properly. This is AB. Okay. T1, T2, and V1. This is not a PV graph that you take the area under the curve. So what is the work done in AB? So I will say AB, it has constant volume. So if AB has constant volume, work done is 0. Okay. What about BC? BC is constant temperature. BC is constant temperature, which means isothermal process. So work done is NR T2 LN V2 by V1. Correct? And CA. So you can clearly see in CA, the slope of volume and temperature curve is constant. What is the slope of volume and temperature curve? The slope of volume and temperature curve is 1 by P. That means pressure. Pressure is constant. So I will say constant pressure. So I will say this is an isobaric process. So work done in isobaric process is P delta V. What is the pressure P? Yeah, so this is nothing but P into V2 minus V1. Sorry, what is the final volume? The process is CA. So final volume is V1, initial volume is V2. So P into V1 minus V2. Final volume minus initial volume. That's why this is nothing but NR into V1 minus V2. As you have V1. Nothing. Okay, use this. I substituted TB1 with NIB1 and TB2 with NIB. Okay. So based on this, correct option is C. Right? Okay, a certain transverse sinusoidal wave has equation. So velocity of the particle at x equal to 0 is equal. So at x equal to 0, the particle which is present at x equal to 0, its velocity and time relation is given. So you can clearly see there is some maximum value of the velocity. From the graph, I mean, even if this is not clearly visible, you can see in your question paper that the Vmax value is basically 5 centimeter per second. Okay. And wavelength, it is given in the question, which is 20 centimeter. Right? You need to find the amplitude. Okay. If you need to find the amplitude, so I will say Vmax is nothing but A omega. Okay. So Vmax is known to us. Amplitude we need to find. What about this omega value? Can I get omega from the time period? So you can see one complete oscillation is done in 4 seconds. Okay. So omega is 2 pi divided by time. So this is pi by. Clear? So right, substitute all the values. V minus is twice integer per second. Amplitude, what is omega? Pi by 2. From here, I will get Q as 10 divided by pi centimeter. Okay. Right? Okay, you need to find the ratio of the intensities IA divided by IB. All we need to know about the intensity is formula for intensity. Intensity is nothing but half of rho A square omega square into V. The V is wave speed, A is amplitude, omega is angular frequency, and rho is the density. So it is same medium, so it is same A. Okay. Right? So same medium means same V and same rho. So if you want to find IA by IB, all you need to do is A1 square omega 1 square divided by A2 square omega 2 square. Right? So what is the ratio of A1 and A2? So let's say this A is first wave, B is second wave. Right? Can I say omega 1 is nothing but 2 pi divided by time period? What is the time period of the first wave? The time period of the first wave is, let's say T1. Omega 2 is 2 pi divided by T2. You can clearly see the time period of first wave is 2 times that of the time period of the second, because first wave is completing only half of the oscillation, when the second wave is completing the complete oscillation. So that's why this is taking more time to complete one oscillation. That's why T1 by T2 is 2. So hence, omega 1 by omega 2 is 1 by. What about A1 by A2? What is the amplitude of this first wave? It is 2 into 10 power minus 2. And A2, the amplitude is 10 power minus 2. So 2 divided by 2. Here, so substitute these values over here. So you are getting 2 square into 1 by 2 square. A1 by A2 is 2. Omega 1 by omega 2 is 1 by 2. Is there cancel? Answer is 1. Okay. Next is, okay, you need to find the graph between dt by dx. This is called as temperature gradient, and area, this particular area. Now you have one particular relation. Q is equal to Ka dt by dx. Okay. So you can see this question is very easy if you understand one thing, that heat flowing through this particular material is constant. There is no heat going out. So whatever the heat is entering from this end, the same amount of heat is going from this end in 1 second. So this is Q is basically the heat flowing in 1 second. So Q is constant. K is obviously constant because it is made up of same material. So I will say K into dt by dx is constant. Okay, so dt by dx is equal to some constant divided by area. You can clearly see this graph looks like y is equal to some constant divided by x. So there is only one graph like that. This looks like y equal to 1 by x. This is y equal to constant by x. So dt by dx is on y-axis, area is on x-axis. So that's why it looks like hyperbola. So only option. Yeah. So in this question, so if you need time to read the question, you can pause the video. That's saying that this is an adiabatic movable separate. The walls, outside walls are adiabatic. Here, this is completely conducting, highly conducting wall. So temperature on both of the sides must be same. This is a conducting wall, hence temperature on both of the sides must be same. And it's free to move. The pressure on both sides should also be same. Okay. and both of them contains 2 moles each, first of all. So what we will do is, heat, the heater is turned on, you need to find the total heat supplied until the pressure in part A is double. So I will say part A and part B. Initially, pressure was, let's say, P naught, volume was V naught, and temperature was T naught. Here, pressure is also P naught, V naught, and T naught. Okay. Okay. Initial pressure is P naught in both of the chambers. Now, if you heat it, what will happen? You will heat it and pressure is double. So this becomes 2P naught. Okay. What about the temperature? So temperature will be, let's say, T. Okay. What will be the temperature over here? Over here also temperature must be T. Both of the chambers must have the same temperature because this separator is highly conductive. So same temperature will be maintained on the both sides. Now you can see this particular separator is also free to move. As it is free to move, it means same pressure. If if it is free to move, and if you change the pressure on either one of the side, it will move in such a way that it will balance the pressure on both the sides. You can clearly see pressure in chamber A and chamber B is same. Temperature in chamber A and chamber B is same. Hence, volume also must be same. Okay. Volume also must be same. Right? Okay. So if volume must be same and number of moles also on both of the sides are same, then the initial and final volume is also same, right? Okay. Now we all we need to do is calculate this temperature, final temperature. How do we calculate the final temperature? Gas now. PV equal to NRT. Let's say for chamber A. For chamber A, I'm writing PV equal to NRT. Final pressure becomes 2 into P into same volume is equal to NR into TA. Okay. So from here, from these two equations, I will get TA equal to 2T. Okay. TA is equal to 2. Hence, I will write it. So understood? TA is equal to 2T. I will going to change in this one. This one. So this becomes 2T. And obviously, as the temperature in both of the samples should be same. This should also become 2T. Yeah. So the main thing in this question was you need to understand pressure in the both of the chambers must be same. As the pressure in the both of the chambers must be same, because why pressure in the both of the chambers must be same? Because this is movable. Also, temperature in the both sides should also be same. Why this should be same? Because it is highly conducting, right? If these two things have to be same, the volume on the both sides that also need to be same. If volume is same, then volume is not even changing. This is even the question, even if the question is saying this is movable, it is actually not moving at all. Okay. So if it is not moving at all, what we can do is if volume is not changing, then clearly see volume is not changing. So it's constant volume process. Okay. For constant volume process, Q is equal to MC to delta. 2 moles of the ideal diatomic gases are there in each of the chamber. So 2 here, total 4 number of moles. CV. What is the value of CV? It is a diatomic gas. So for diatomic gas, CV is 5 or like that. Into delta T. What is the value of delta T? Finally, the temperature becomes T naught. Initially, the temperature is T naught. Do the calculation. You will get 4 into 5 by 2. But R value is given to as 5 by 3 into T naught is nothing but 300. Okay. So the answer is, so you will get this as 25 and 25 kilojoules. Okay. Option D, 25 kilojoules. Everything is in SI units. That's why the Q is also in SI units, 6 joules. The beaker contains 200 gram of water. The heat capacity of the beaker is equal to 20 gram of water. This is a beaker. Okay. It contains 200 gram of water. And I will say this is equivalent of, this is equivalent of 20 gram of water. Okay. Initial temperature is 20 degrees Celsius. So initial temperature is 20 degrees Celsius. A 440 gram of hot water, 440 gram of hot water at 92 degrees Celsius is poured into it. The final temperature will be nearest to. So first of all, let's say you are pouring some 440 gram of hot water. Its temperature is going to go from 92 to let's say some temperature T. This is the value which we need to find. Now, how about the water which is already present here? So I will say the water plus container, they are going to go from 20 degrees Celsius to temperature T. Okay. So I will say heat absorbed by water plus container is equal to heat released by hot water. Okay. So what is the water plus container? So water is 100 grams and this container is basically equivalent of 20 gram of water. So just do this 200 plus 20 into specific heat of water is 1. I would say calorie per gram per Celsius. So this is in grams. So I can write 1 into delta T. What is the change in temperature? T minus 20. This is the heat absorbed by the container and water. What is the heat released by hot water? Hot water is of 440 gram into specific heat 1 into it is heat released. So temperature will drop and it is 92 minus. Okay. Right? If you do the calculation from here, you'll get this T minus 20 is equal to 2 into 90 grams. If you do the calculations, you'll get 68 degrees Celsius and temperature. On the reading of 68 degrees Celsius. Clear? This standard calculation. Just two different liquids mixed. So the difference is you can replace this beaker with 20 grams of water. That's all I need. Okay. One mole of hydrogen monoxide gas compressed isothermally. Compressed isothermally in a rigid vessel to double its pressure at room temperature. So isothermally pressure becomes P0 to P0 and temperature is nothing but 300 Kelvin, 27 degrees Celsius with 300 Kelvin. Work done by the gas. Work done on the gas. Work done on the gas. So work done on the gas is basically minus of NR T naught, NR T, ln of T2 by Q1. No, not T2 by Q1. This is actually V2 by Q1. So if it is V2 by Q1, it should be V1 by Q2. Right? So this is 1 mole minus of 1 into R. T naught is 300. ln of what is P1 by P2? P1 is P naught. P2 is 2P. So this is nothing but 300 R ln. Yeah. Work done on the gas is basically negative of the work done by the gas. That's why it's negative step. And work done by the gas in isothermal process is NRT naught ln T1 by P2 or V2 by V2. We don't have volume, that's why I got the pressure equation. Next. Okay, final answer is this. 300 R ln. Okay. Next one. A mass of hydrogen gas molecule is mass of the molecule is given to you. Mass of the molecule is given. Number 10.23 hydrogen molecules right per second. Unfixable bond is given. Area is given. Okay. 45 degrees angle is given. So let's say this is the hydrogen molecule. It strikes at 45 degrees and it will go like this. Rebounds elastically. Speed is also given to you. Okay. You have to find the pressure on the ball. How do you find the pressure on the ball? First of all, we need to find force. Can I say force is basically change in momentum in 1 second? Okay. What is the change in momentum due to one molecule here? When one gas molecule, so when one hydrogen molecule is retained, its momentum is changed by so the component of the velocity along the surface is not changing. Only the component of the velocity, which is perpendicular to the surface, is going to change. It's going to change from v by to again v by 2, but the direction will be opposite. Okay. So delta P is going to be 2 into m into v by root 2. This is the change in momentum due to one hydrogen molecule. Okay. This is the change in momentum due to one hydrogen molecule, which is nothing but root 2 into m. What about the change in momentum in 1 second? So in 1 second, 10 power 23 hydrogen molecules are colliding. So it is root 2 mv into 10 power 23. Okay. So that is the force. How about pressure? Pressure is nothing but force divided by area. So this is nothing but root 2 mv into 10 power 23 divided by area is 2 centimeter square, which means 10 power minus 4 meter square. You already know the value of mass. Mass is the 3.32. So root 2 the 3.32 into 10 power minus 27 into velocity is 10 power 3 meter per second. So this 10 power 23 divided by this 2 into. If you do the calculation, you are going to get 2.35 into 10 power 3 Newton per meter. This is your again calculation very proper, but the concept is you have to calculate the force. From force, you can calculate the pressure. And force is basically change in momentum 1 second. Okay. Temperature of an open room of volume increases from 70 degrees Celsius to 27 degrees Celsius. Or else, in other words, I can say 90 Kelvin to 300 Kelvin. You have to find, so let's say Ni and Nm are the number of molecules in the room. So Ni are the number of molecules in the room before and after. So Ni is the number of molecules in the room at 290 Kelvin, and Nf are the number of molecules in the room at 300 Kelvin. You have to find Nf minus Ni. So again, this is standard feed equal to gas question. This N is number of moles. Can I say this number of moles? So let's say Pi is equal to Ni by Na into R into Ti. Okay. This is the initial condition. What is the initial condition? Initial condition is when temperature is 290 Kelvin. So they are saying the pressure is constant, volume is also constant, number of moles are changing and temperature is changing. So can I say Ni is nothing but, or another word, what is the value of Pi? So I will say V naught into Avogadro number divided by R into K. I know P and Pi not because pressure and volume are constant is equal to initial number of molecules in the room. What about final? So before that, I will try to calculate this. So N is going to be V naught, Avogadro number divided by R into Ti, temperature is 290. Okay. What about finally? Finally, pressure is going to be V naught, same pressure, V naught, same volume is equal to Nf divided by Na. These are the number of moles. Nf is total number of gas molecules divided by Avogadro number, that is total number of moles. into R into 300. This is the final condition. So N is nothing but V naught, V naught, N divided by R into 300. You need to find NF minus N. Okay, only the temperature difference is there. So write down that V naught, Na divided by R into 1 by 300 minus 1 by 200. What is the value of V naught? I think it is given. Atmospheric pressure 10 power 5. V naught is just given 30 meter cube. Have a calculator 6.022 into 10 power 23 divided by R value is 8.314. Everything is in SI units into 1 by 300 minus 1 by 200. You can see you are going to get some negative answer, and that negative answer is approximately equal to, I did the calculation, is approximately equal to minus of 2.5 into 10 power 25. Okay, this is result in this. Okay, yeah. So just write down PV equal to NRT for initial and final condition and subtract to get the final answer. It says that in a closed vessel, some ideal gas contains. It is moving with velocity v. You have to find the rise in the temperature when the vessel is suddenly stopped. When vessel is stopped, when vessel is stopped, I will say the kinetic energy of the vessel which was there initially, it is being converted into internal energy. Internal energy of the gas. You may say it is converted into heat as well, but it doesn't matter. Work done is zero. So as the volume is not changing, so as the volume is not changing, internal energy and heat both of them are same. So you can see the kinetic energy is converted into internal energy. You can write kinetic energy as half of mt. This mt is the total mass. Mt is the total mass of the gas in the vessel into V square. That should be equal to NCV delta T. Okay. Can I write this number of moles as total mass divided by molecular weight into Cv? I can write it as R divided by gamma minus 1. Cv is equal to R by gamma minus 1 is one relation that we have. Delta T. This is half of MT into V square. If you rearrange the terms, you are going to get delta T equal to, in denominator you are going to have 2R. This MT will be cancelled. In the numerator, you are going to have M P square and gamma minus 1. Okay. Okay. You done final. Right? We go to next question. The mean free path and average speed of the oxygen molecules at 300 Kelvin and 180 atm is, so mean free path and say in lambda, it is 3 into 10 power minus 7 meters. And velocity of the gas molecules is 600 meter per second. Then the frequency of the collision. Okay. Can I say the frequency of the collision is nothing but 1 by time between the collisions? Okay. Now, how do I calculate the time between the collisions? Time between the collisions is basically mean free path divided by velocity. Distance divided by velocity is time. Or in better words, I can say this mean free path is nothing but the average distance between the collisions of the two molecules. So yeah, this is the distance between the distance taken by the molecule for the collision, and this v is the speed with which that molecule was traveling. So this is the time for one collision. So this is nothing but 3 into 10 power minus 7 divided by 600. So it's nothing but 10 power minus 9 divided by 2. Just substitute this value over here. Frequency is 1 by time between the collisions is including by 2 divided by 10 power minus 9. So yeah, 2 into 10 power 9 meters per second. Oh, 2 into 10 power 9 hertz. Or you can say 1 by second. Okay, next one. Okay, this one is very lengthy question. It says that pressure and volume, the relation between pressure and volume is given to you. And initially, that saying is V naught is basically 8 liters. Okay. And the volume of the gas will increase. In some range, the gas expands with absorbing the heat, endothermic reaction. In other range, it expels the heat. You have to find the volume after which the volume of the gas is further increased. Then the process switches from endothermic to exothermic. So when the process reaches from endothermic to exothermic, I can roughly say the Q value goes from negative to positive. Okay. When the Q value goes from negative to positive, dq by dv value goes from negative to positive. That means for the given increase in volume, the change in heat. Endothermic means you are increasing a volume by some quantity. For the given change in volume, what should be the change in the heat? So if that heat is negative, you can say it is endothermic. And when that heat is positive, you can say it is exothermic. So basically, for the given volume, if the change in heat is going from negative to positive, then we will say the reaction is going from endothermic to exothermic. So when this happens, when this term is going from negative to positive, in between this, the dq by dp is going to be zero. Okay. So this is all you need to find the answer of this question. At what volume dq by dp is zero? That is what I have to calculate. First of all, how do I get the equation of Q? So what I will do in this question is, I need to make sure that dq by dv is zero. So for that, I need equation of Q. How will I get the equation of Q? Q will be equal to delta U plus work done. Okay. But you have formula for delta U as NCB delta T. You don't want temperature in this particular equation. You want volume uh, for the Q. So what I will do is, I'll write down the value of filtering and W. I will convert them into volume. I'll write down some equation of Q for the volume and then differentiate it and make it simple. Okay. So I'll do this on the new slide. So this is the plot. Okay. Let's say, and this is how it was going to be. This is V naught. This is V naught. Let's say this is V1. This is V naught. This is P1. And let's say EB point over here. Okay. Let's say this point is P and this point is B. Okay. So I would say that at this particular position, here dq by dv is equal to 0. Right? At this particular position, dq by dv is 0. So you have to find that volume. You have to find this value of V for this dq by dv. So how do I calculate the Q value at this particular position? I can write Q is equal to delta U plus W. Okay. I will go step by step. First of all, I'm bringing this W. How can I calculate W here? To calculate W, you have to calculate the area between this area under the curve. So basically area under PV curve. From where to where? So let's say here temperature is T1, here temperature is T. from 10 to T1 up to T. Can I say that area is basically this is the rectangle? So the area of the rectangle is basically half of P1 plus P into V minus V1. So this particular value is so I calculated this complete area. Okay, I'm going from T1 to T. So if I'm going from T1 to T in this particular process, what is the area under the curve? That area under the curve is this. You can calculate that area under the curve. This is nothing but curve. Clear? Okay. Then what about delta U? Delta U is nothing but M single delta T. Right? I believe gamma is going to be one mole of ideal monoatomic gas. So it is monoatomic gas. So for monoatomic gas, this equation basically becomes N 3R by 2 into T minus T1. Okay. So 3 by 2 NRT minus NRT1. So PV minus P1. I will do so basically NRT minus NRT. I'm calculating the thinking that the pressure is going from P1 to P, temperature is going from P1 to P, and volume is going from P1 to P. Basically, this is the process which I'm making. Okay, this is the value of delta U. I can also write this delta U as P by 2 into what is the value of NRT? This is NRT. Okay, so can I say NRT is nothing but PV? PV is equal to NRT minus NRT1. What is the pressure and volume at this particular point? This B1 and B1 minus of P1 and P1. Okay. So now you have delta U, you have work done. Simply add them. K is equal to delta U plus W. In other words, delta U is 3 by 2 PV minus of 3 by 2 P1 V1 plus W half of P1 P minus PV plus minus of P1 V1. This is, I'll write this again. So work done. I'm writing the work done only. So P1 into V minus P1 into P1 minus of P1 into V. Okay. This is P into V minus P into V. P into V minus P into V. Okay. This is the equation. You need to make dq by dv is equal to 0. But you can see so many unknown terms are here. You have to eliminate P somehow. You have to eliminate pressure. Okay. You have to eliminate the pressure. So if you have to eliminate pressure, I will simplify this first of all. If you have to eliminate pressure, I need to find the graph relation between pressure and volume. How do I find the pressure relation between pressure and volume? I will say from the graph. This is a straight line. This is a straight line. So what is the equation of the straight line? You can see it is going to intersect the x-axis at V0 and y-axis as P0. Hence, its slope is minus of P0 by V0. So P is equal to minus of P0 by V0 into V. Y equal to slope into S plus C P0. Okay. From the graph, you have this equation. So what I will do is I'll substitute the value of P over here. Can I also say P1 is equal to minus of P naught by V naught into V1 plus P. Okay. So wherever you see P in this equation, substitute this value. Wherever you see P1 in this equation, substitute this value. Okay. So there will be a very long equation. I will directly write down what I get the result from that. I write down this as minus of P1. Okay. So you might be thinking where, so you might be thinking where those P1 and P gone. I replaced all the P1 and P with these equations. So in the equation at the end, I will be only expecting P naught, V naught, and V and V1. Only these type of terms will be there. And I'm getting these terms only. Now make the dq by dt as 0. So you can try this by yourself. Just have to substitute these two values over here because P and P1 they are unknown for me. That is why I have to substitute the value. If you substitute the value, you are going to get something like this, and then dq by dt make it 0. You can clear this thing. This one is constant, and this thing is also constant. So by differentiating, both of them are one. Differentiate this thing. Minus of 4 P naught V by V naught plus 5 P naught by 2. Okay, that should be equal to 0. So P naught is also cancelled. I'm getting V as V is equal to 5 V naught by 8 from here. Clear? And in the question it was given that V naught is equal to 8 meter. This is given in the question. V naught is equal to 8 meter. This is given in the question. If you substitute the value, will get V is equal to 5. Okay, right? Okay, next one. Okay, if I have to go back to this question, try to summarize this. You have to find the volume at which the process goes from endothermic to exothermic. Basically, the process at which dq by dv is equal to 0. If you want to make dq by dv as 0, find out the q in terms of v. So you know the relation between pressure and volume from here. So I will try to find Q from V. Q is equal to delta U plus W. After that, delta U is this. Okay. Simple NCV delta U. And work done is basically area under the curve. I wrote the work done here. Work done is this. Just add them, you will get Q. If you substitute here, P is unknown to me. So I will replace the value of P from here. It is going to become a very long equation, but after simplifying, you are going to get this. That way you will have two constant terms, P naught, V naught, V1, they are all constants. That's why these are the only two terms on which the V variable is there. So differentiate that, make it equal to 0, you'll get the final answer. Okay. Next one, the Carnot engine operates between two reservoirs at temperature given. The engine performs The engine performs 1200 joule of work per cycle. Heat energy delivered by the engine to the low temperature reservoir in the cycle is. This is simple formula based question. So all I need to do is I say Q1 is the heat absorbed from the high temperature, Q2 is the heat released to the low temperature plus W. Okay, and I can write Q1 by Q2 is basically T1 by T2, or instead of this, I can simply say efficiency is nothing but work done, WD is work done, divided by heat input, which is Q1. So what is the efficiency? Efficiency is 1 minus 300 by 900. Efficiency of the Carnot engine is 1 minus T2 by T1. T2 is 300, T1 is 900. That should be equal to work done is 1200. What is the value of Q1? That's all that is not there. So write down this Q1. 2 by 3 is equal to 1200 bar Q1. I got Q1 equal to 1800 joule. Okay. So if I get Q1 as 1800 joule, I can use this equation over here. Write out Q1 as 1800. Q2 is this plus work done is 1200. I get Q2 as 600 joules. So remember the sign convention. Q1 is the heat absorbed by source, Q2 is the heat released to the sink, and W is obviously the work done. And T1 is the T1 is this 900, T2 is 300. So answer is 600. We got the answer. Okay. Next one. Suddenly compressed to the 1 by 8 of its initial value. So suddenly compressed means this process is adiabatic. Suddenly compression means there is no time for heat to loss, no heat loss, adiabatic process. The ratio of final pressure and initial pressure is, yeah, this is really simple. P power gamma is equal to constant. Okay. Or you can also say it is thermally insulated. As it is thermally insulated, it is an adiabatic process. So I will write V1 power gamma equal to P2 power gamma. What is the initial pressure? P1. What is the initial volume? Let's say initial volume is V. So it is compressed. The question says it is compressed to 1 by 8 of its initial volume. So let's say initial volume is V0. Will be equal to P2 into V0 by 8 power. What is the gamma? Gamma value is 5 by 3. And also gamma value is 5 by 3. So basically, volume is going from V0 by 8. Here, this is initial volume, this is final volume, and the gamma is equal to 5 by 3. It is given. So hence, P1 by P2, okay, is equal to ratio of final and initial. So final initial is P2, initial pressure is P1. This is equal to this 8 power 5 by 3. We not power 5 by 3 cancel. So 8 power 5 by 3 is there. What is 8 power 5 by 3? 2 power 3 into 5 by 3. So this is the number 2 power 5, which is 30. Okay? Answer is 30. Right? Next one. Helium and argon gas, both are monatomic gases. Temperature is 300 Kelvin. Okay. The ratio of average kinetic energies per molecule. Obviously, both of them are the monatomic gas. So kinetic energy average is not average kinetic energy is average kinetic energy per molecule. Instead of average kinetic energy, average kinetic energy per molecule. What is the kinetic energy per molecule? 3 by 2 kT. Okay. There is no need of molar mass here. So average kinetic energy, or basically the simply kinetic energy of one molecule, it only depends on temperature, not on the molecular weight. If both are monatomic gases, so it does not depend on the molecular weight. Hence, as the temperature is same, answer is 1. Okay, same kinetic energy will be there for both of the gas molecules. So that's why answer is 1. Again, it does not depend on molecular weight. So only depends on temperature. And as the temperature is same, the energy will also be the same. Okay. Okay. So this 50, this is also related to basic thermodynamics. It says that there are two results filled with ideal gas. So these are the two results filled with ideal gas, where volume of one of the is double. Okay. So volume is let's say 2V0, here volume is 3. The large vessel contains gas at 8 kilopascal and at 1000 Kelvin. Okay, while the smaller vessel contains 7 kilopascal and at 500 Kelvin. Okay, if they are connected to each other by thin tube, the connected to each other working tube, allowing the gas to flow, and temperature is maintained at 600 Kelvin. So finally, I will say this large vessel, its temperature is going from 100 to 1000 to 600. And this, I will write down that finally, the temperature becomes 600 Kelvin. Pressure will have some value. Pressure will be, let's say, P. Volume is going to be 2V. Okay. Volume is going to be, let's say, okay, volume is going to be 2V. So, volume is known. Similarly here, finally, the temperature is going to be 600 Kelvin. Obviously, that mixed, so the temperature must be same. Also, pressure of this gas and this gas, those pressures should also be same. So I'm writing the same pressure on the both sides. We don't know this pressure. I believe we have to calculate this pressure on this. And what will be the volume? Volume will be we know. Okay. So that's all we have to find. We have to find the pressure. Again, writing the PV equal to NRT, which is the gas law equation for initial and final things. So I say initially PV equal to NRT. So for this particular gas, it is 8 kilopascal into volume is 2 V naught will be equal to, let's say, n1 number of moles are there. N1 moles are there, here n2 number of moles are there. So n1 into, what is the temperature here? 1000. Correct? What about this one? 7 kilopascal into volume is V naught equal to n2. N2 number of moles are there. What is the temperature here? 500 Kelvin. Okay? This is the initial condition. I would say finally, when both of them are combined, when both of them are combined, when both of the gases are combined, I will say that combined pressure P into what is the total volume? 3 V naught. Talking about the complete full gas, this 2 V naught plus V naught, which is 3 V naught, will be equal to. So if I'm combining both of the gases, V naught, 2 V naught and V naught, the number of moles should also be combined. So total number of moles in the entire container is N1 plus N2 into their final temperature is 600 Kelvin. Isn't it? So simply compare this equation and this equation. So obviously from this equation I can say N1 is nothing but 16 V naught divided by 1000 R and N2 is nothing but 7 V naught divided by 500 R. Okay. Substitute this N1 and N2 values. I will get 3P V naught equal to N1 16 V naught by 1000 R plus N2 7 V naught by 500 R into R into 600. You can clearly see the V naught is cancelled, R is also cancelled. So you are left with 3P is equal to 16 by 1000 plus 14 by 1000 into 600. Okay. So after this, we get P is equal to 6 kilopascal. Correct? So let P is equal to 6 kilopascal. Unit is kilopascal because I got 8 and 7. So if I like 8, if I like 7, 8 is in kilopascal. So that's why finally whatever answer I'm getting, that will also be in kilopascal. Right? Okay. This is only related, this is only gas law equation. PV equal to NRT, PV equal to NRT. I wrote the two equations, and then finally also I wrote PV equal to NRT. I just compared these three, and I got the value of the equation. Yes.